I will show you an example of how we can make use of the reduction formulae to simplify trigonometric expressions. First of all, please take note. In quadrant 1, we can write our angles there in the form 360 degrees plus theta. And in quadrant 2, our angles can be written in the form 180 degrees minus theta. And now for an angle that lies in quadrant 3, we can find a way to write that angle in the form 180 plus theta, where theta is acute. And same for quadrant 4. If an angle lies in quadrant 4, we should be able to get a way to write that angle in the form 360 minus theta. Then we just need to know the relationships, those reduction formulae there. In quadrant 1, all ratios will be positive. In quadrant 2, it's only the sine ratio that is positive. In quadrant 3, only tangent is positive. And in quadrant 4, only cosine is positive. It is very important to start by learning these reduction formulae and actually understand why they come to become what they are. Let's look at an example where we can use the reduction formulae. We need to simplify this expression. Sine of 330 degrees multiplied by tan of 210 degrees divided by sine 390 degrees multiplied by tan 150 degrees. And we should do this thing without the use of a calculator. Let's start with simplifying sine of 330 degrees. The angle 330 degrees should be in quadrant number 4. So 330 is in quadrant 4. And we said angles in quadrant 4 can be written in the form 360 degrees minus something. So let's find a way to write 330 degrees in the form 360 subtract something. Clearly, 330 degrees should be the same thing as 360 degrees subtract 30 degrees. So we can now rewrite that expression in the form 360 degrees subtract 30 degrees. Right. Now let's look at 210 degrees for the tangent there. 210 is in the third quadrant, and we said angles in the third quadrant can be expressed in the form 180 plus some acute angle, theta. So now for 210, we can add 30 degrees to 180, and that will give us 210. So we can rewrite the tan of 210 as 180 degrees plus 30 degrees. So the tan of 210 is the same thing as the tangent of 180 degrees plus 30 degrees. Now let's look at the sine of 390 degrees. Again, you will notice sine of 390 degrees should be in quadrant 1. And this is because if we start measuring from 0 degrees here, we are able to complete a revolution, 360 degrees, but we are looking for 390 degrees. And so 390 degrees is the same thing as 360 degrees plus something, and in this case, we are adding a 30. Right, hope you see that. So to get 390, starting from 0, you have to complete a revolution, but on top of that, we need to add another 30. So we will end up in the first quadrant. So now we can rewrite sine of 390 in the form 360 degrees plus 30 degrees, like that. Okay, then the tangent of 150 degrees. 150 degrees clearly is in the second quadrant. And we said in the second quadrant, we are able to write our angles as 180 degrees, subtract something acute. So it's 180 degrees in this case, subtract 30 degrees. Now that will give us 150. So we're going to replace 150 degrees with 180 minus 30. And so we can now rewrite the tan of 150 as tan of 180 subtract 30 degrees. Now the next thing is, remember the reduction formulae. If you know that sine of 360 minus theta is equal to negative sine theta, then you should be able to simplify the sine of 360 degrees minus 30 degrees. And so that will give us, because that is in the fourth quadrant, and we know in the fourth quadrant sine is negative, so that will give us negative sine of 30 degrees. Now for the tan of 180 plus 30, 180 plus 30, which is 210, is in the third quadrant. And in the third quadrant, tangent is positive. So tangent is positive. So we will get a positive result. And in this case, that should be the tangent of 30 degrees. Then for sine of 360 plus 30, 360 plus 30 is in quadrant 1. In quadrant 1, sine is positive. So we have positive sine. And now we have reduced that to 30 degrees. So it's sine of 30 degrees. And then tan of 150 degrees, which is the same as tan of 180 minus 30 degrees. This is in quadrant 2. And in quadrant 2, the tangent ratio is negative. So we expect a negative, and that will be negative tan of the acute angle, which is 30 degrees. Now you can simplify this. And these will cancel out, so those will cancel out. And so we end up with an answer of 1.